Assalamualaikum warahmatullahi wabarakatuh. So, my name is Ashraf Basri bin Azmi, and my team for the topic of our presentation for today is momentum. Our team has 5 people in it. The first one is going to be Muhammad Ryan Imran bin Muhammad Zafir, and me, Ashraf Basri bin Azmi. The third one will be Muhammad Firdaus bin Abdul Rahman. The fourth will be Muhafiq Hayat bin Mazrat, and the last one will be Adam Ifan bin Rosli.
Hi everyone, today I will be presenting about one of the most essential appliances in any household, the refrigerator. So first, the brand identity. We use Panasonic refrigerators stand out way to their strong brand identity. They are known for combining Japanese engineering excellence with cutting-edge technology and a commitment for sustainable living. This means you are not only getting reliability, but also innovation and eco-conscious performance. So for application, refrigerators serve a variety of purpose. So first, for domestic application. So they are used in our home to preserve food and drinks, keeping them fresh for longer. So for industrial setting, refrigerators are used on a large scale. For example, in factories or cold storage, warehouses where maintaining low temperature is critical. So the main function of a refrigerator is to preserve food and beverage by keeping them at low temperature. This helps prevent spoilage, extend shelf life, and contribute to overall food safety in the home. So for price range, when it comes to cost, Panasonic offer range to suit different budget. Entry-level model are priced between 1,699 and 2,149. For those looking for more features or larger capacities, the premium multi-door model are available from 3,988 to 4,299. So, in summary, Panasonic refrigerators are reliable, efficient, and smart investment for both home and industrial use. With a balanced innovation, affordability, and sustainability, they meet the needs of modern consumers. Thank you.
I'm going to talk about mechanism. Working principle. Compressor. The compressor compresses the low pressure, low temperature refrigerant gas, usually R16A, in a compression mode. In a higher pressure and higher gas, this increases the energy of the refrigerator and sends it to the condenser. Condensation. The high pressure hot gas passes through the condenser coil located at the back or the bottom of the fridge. As it cools down, the refrigerator releases heat the surrounding and condenses into the high pressure. 3. Expansion. The higher pressure liquid refrigerant passes through a capillary tubes and expansion valve which reduce the pressure. As the pressure drops, the refrigerator becomes cold, low pressure liquid. 4. Evaporation. The cold refrigerator enters the evaporator coil located inside the fridge. Here it absorbs heat from the item stored inside the refrigerator, developing back into a gas. This cooling effect temperature inside the fridge. The low pressure gas turns into compressor and the cycle continues.
Okay, now let's move on to types of working fluid. First, we have R600A or isobutane. It's the most common refrigerant used in modern fridges. It's energy efficient and better for the environment. Second, we have R134A. This one is found in older model, but it's less eco-friendly, so that's why it's being used less today. Then lastly, we have R290 or propane. This fluid is very efficient and good for the environment, but it needs to be handled safely because it's flammable.
Momentum flow theory. The force exerted by the refrigerator flow can be described by F equal to M V out minus V in. F. Reaction force on the compartment. M. Mass flow rate of refrigerator. V in and V out, inlet and outlet velocity of the refrigerator.
Right now, I will present about Bernoulli principle and Reynolds number in refrigerator system. So first, Bernoulli principle help us understand how pressure changes with velocity in a flowing fluid. So, the equation you see here shows the relation between pressure and velocity. So we apply using R134A refrigerator in vapor phase, okay, with a density of approximately 20 kilograms per cubic meter. In this example, the inlet velocity is 2 meters per second. The outlet velocity is 20 meters per second. So using the equation, we calculate the pressure drop. So 0.5 times 20 times. So this is just example, okay? So using the equation, we calculate the pressure drop. 0.5 times 20 times 20 square minus 2 square equals to 3,960 Pascal, about 3.96 kilopascal. They show a significant pressure drop due to increased velocity, which is common component like expansion valve or compressor. So number 2 is for Reynolds numbers. So Reynolds numbers tell us whether the flow is laminar or turbulent. This is cru crucial, critical, just like seem like that, critical for efficiency and performance is part like capillary tubes and evaporators. Using liquid R134A with a viscosity of about 0.0002 Pascal seconds. So assume flow velocity is 1 meter per second. Tube diameter is 0.01 meters. So we plug the values in the formula. Re equal to PVD over equals to 1200 times 1 and times 0.01 over 0.0002. So that means you can get 6,000 indicates turbulent. So which means more mixing and heat transfer, but also more resistant. So in conclusion about my parts is both Bernoulli and Reynolds number help us analyze fluid flow behavior in refrigerator system and understanding this allows engineer to design components like expansion valve and tubes more efficiency. So for my mistake that when I say a formula for Reynolds numbers is Re equals to PVD over viscosity equals to 1200 times 1 times 0.01 over 0.002 equals to 60. That's only I want to edit, and thank you.
Thanks to Adam. Now let's move on to the Mach number. The Mach number is the ratio of the local flow velocity V to the speed of sound, which is c. In refrigerator, the airflow is usually quite slow, around 5 meters per second, while the speed of sound is about 343 meters per second. So when we calculate the Mach number, we get a very small value, which is 0.0146. This shows that in refrigerator, compressibility and high-speed flow effects are negligible. That's why the Mach number is not important in refrigerator design or analysis. Now let's move on to the Froude number. It is defined as the flow velocity divided by the square root of gravity times length. This number is more relevant in systems where gravity affects flow significantly, like open channels or free surface flow. But in refrigerator, the flow of motion is driven mainly by forced convection, using fans or natural convection due to temperature differences. So again, the Froude number isn't a key parameter either. Instead, what really matters in refrigerator system are things like thermal performance, pressure drops, refrigerant cycles, and the coefficient of performance.
Thank you, Firdaus, for the explanation about Mach number and Froude number. Now I will explain about encountered problems. First, we have cooling issues. This occurs when the fridge is not cooling enough or is unable to freeze food. Some typical causes include dirty condenser coils, which reduce heat dissipation, a faulty evaporator fan that blocks the circulation of cool air, and low refrigerant charge, usually due to leaks or improper charging. The recommended fix for this problem is to clean the coils, check the fans, or if needed, call a technician to check the refrigerant leaks. Next is excessive frost buildup in the freezer, especially on the evaporator coils. This may due to defrost heater failure in auto defrost models, a faulty defrost thermostat or timer, or a door left open or one with a bad gasket which allows humid air inside. The solution here involves replacing the heater or thermostat and checking the door gasket for proper sealing. The third issue is water leakage, where puddles form inside or under the refrigerator. This is often caused by a clogged defrost drain blocked by ice, a cracked water supply for the ice maker, or a misaligned drip tray. Fixing this involves clearing the drain with warm water and inspecting the water supply lines and drip tray. Lastly, we often hear strange noises like buzzing, clicking, or rattling. These sounds can come from a faulty compressor, which causes loud buzzing, a loose fan blades, or debris in the condenser fan or ice maker valve issues, which can cause clicking noises. To resolve this, we can tighten loose components, clean out the fans, or replace the compressor if needed. Next, I will pass the presentation to my friend Ashraf.
And I also going to talk about suggestion on improvement about refrigerator of Panasonic. The first one, we can talk about the improvement on the thermal efficiency, which is we're going to use a better insulation, such as upgrade to vacuum insulated panels to reduce heat gain through walls. For the second one, we talk about enhanced energy efficiency, such as inverter compressor. If possible, replace fixed speed compressor with an inverter compressor to save energy and reduce cycling losses. The third one, we're going to use an optimized air circulation for the multi-airflow design. For that, we can add or reposition internal circulation fans to improve temperature in uniformity and prevent hotspot or freezing zones. And the last one, improve refrigeration cycle efficiency. We're using such as optimized heat exchangers, use micro channel or enhanced fin tube design for evaporates and condensers to improve heat transfer.
To wrap our discussion, let's look at the bigger picture behind how a refrigerator works. While refrigerators primarily operate based on thermodynamics, where heat is moved from inside the fridge to the outside, there's another important concept at play: momentum flow. As the refrigerant moves through the components like the compressor, coils, and capillary tube, its speed and pressure change. These changes directly affect how smoothly and efficiently the refrigerant flows through the system. By applying momentum flow theory, engineers can design better refrigerator components, ones that reduce energy losses, improve refrigerant movement, and help the system run more efficiently overall. So, even though momentum isn't the main principle behind refrigeration, it still plays a significant role in enhancing the refrigerator's overall performance and energy efficiencies. That's all from me, and that's all from us. Thank you.